Hello, space enthusiasts and cosmic curiosity seekers. Today, we're diving deep into an extraordinary discovery that's lighting up the universe of astronomy. The James Webb Space Telescope, a marvel of modern science, has just sent back data revealing a new planet, and get this, the lights are on. Stick around as we unpack this stunning find and explore what it means for our understanding of the cosmos. In a thrilling revelation, scientists have announced the discovery of a new planet, unlike anything previously known. NASA, celebrated for its pioneering research, has disclosed that this planet captivates not merely due to its size and position, but because it emits a light that seems artificial. This groundbreaking discovery prompts a tantalizing question. Are we on the brink of uncovering cosmic secrets that could redefine our grasp of the universe? Could this evidence suggest the existence of extraterrestrial life? As we delve into NASA's incredible findings, we anticipate learning more about the mysterious lights. Back in 2007, NASA launched the Dawn spacecraft, tasked with exploring some of the most fascinating objects in our solar system. Outfitted with 3 ion engines, Dawn embarked on a voyage that started with a comprehensive 14-month study of Vesta, the second largest asteroid in the asteroid belt. Dawn transmitted back detailed images and data that unveiled Vesta's intricate surface and varied geological history. After concluding its mission at Vesta, Dawn initiated the second and possibly more exhilarating phase of its journey, a meticulous exploration of the dwarf planet Ceres. Thanks to its ion engines, Dawn successfully left Vesta's orbit and set its course toward Ceres, a feat that traditional chemical propulsion could not have achieved. These engines have opened new doors in space exploration, allowing us to reach and study distant celestial bodies like never before. In an awe-inspiring feat of engineering, Dawn utilized its gentle but powerful ion propulsion to traverse vast distances and achieve a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt situated between Mars and Jupiter. For many years, it held the title of the smallest recognized dwarf planet until its reclassification in 2006. With a diameter of approximately 950 km, Ceres stands as the largest and most massive body in the asteroid belt, captivating scientists with its unique characteristics. The scientific community was abuzz with anticipation for the first detailed images of this enigmatic world. These images, particularly from a large crater named Ocator, revealed mysterious bright spots that ignited a flurry of speculation and excitement. Before dawn, the best views we had of Ceres were through the hazy, low-resolution images captured by the Hubble Space Telescope, which left much about the dwarf planet shrouded in mystery. The promise of a close-up view through Dawn's mission was a beacon of potential discoveries. This mission was not just about getting a closer look, it aimed to deepen our understanding of the solar system's formation and the processes that shaped these celestial bodies. As Dawn continued its journey, each revelation brought us steps closer to unraveling the cosmic mysteries of our solar neighborhood. The bright spots on Ceres, also noted on other asteroids, could be made of highly reflective materials, possibly salts left by sublimated water. This intriguing find hints at the possibility of cryovolcanism on Ceres, where volcanoes may erupt with liquid water or brine instead of molten rock. But what exactly are these enigmatic lights, and what do they tell us about Ceres? Could they be signs of active geological processes, or perhaps something even more remarkable? Ceres distinguishes itself from other celestial bodies in the asteroid belt with its size, mass, and composition, suggesting it may harbor water and ice. Unlike the typical rocky asteroids, Ceres exhibits a more comet-like makeup, hinting at secrets that could illuminate aspects of the early solar system. After a 2-year journey, the Dawn spacecraft began its final approach to Ceres in early 2015, marking a significant milestone. As it neared, the spacecraft's increasingly detailed images began to unveil a world brimming with potential revelations. This pivotal moment was set to provide humanity with its first intimate look at the largest object in the asteroid belt, promising to reshape our understanding of these distant realms. The first images of Ceres peeled back layers of mystery, revealing a cratered surface etched with the history of countless impacts. What captured the imagination of scientists and space enthusiasts alike were the luminous spots scattered across the dark, rocky terrain. As the image resolution sharpened, the scientific community buzzed with theories about these bright spots. Were they simply patches of ice reflecting sunlight, or something far more exotic? Speculations swirled around possibilities from mineral deposits to telltale signs of cryovolcanic activity. To everyone's astonishment, closer examination showed that the brightest spot was not a singular entity, but a conglomerate of several distinct spots. The prevailing theory emerged that these were salt deposits left by the sublimation of water, indicating that Ceres either had, or still possesses, active geological processes capable of transporting water or brine to the surface, where it quickly evaporates, leaving behind brilliantly reflective residues. These revelations challenged previous notions about Ceres, painting it as a dynamic and complex world, far beyond what had previously been imagined. Each new detail added depth to our understanding of this enigmatic dwarf planet, hinting at a celestial body teeming with geological secrets waiting to be uncovered. The potential existence of groundwater or brine pockets on Ceres could profoundly shift our understanding of life's possibilities within our solar system. Ceres' unique makeup includes a surface blend of water ice and hydrated minerals like clays and carbonates, giving it a less dense structure than its rocky neighbors. This suggests that Ceres harbors a significant amount of water within its surface layer. Its composition, rocky yet porous with pockets of ice and other volatiles, resembles a comet more than a typical asteroid. The internal structure of this dwarf planet is equally compelling, believed to comprise a muddy mantle surrounding a core enriched with water ice, which constitutes about 50% of Ceres' total volume. The mantle likely mixes rock with brine, encasing a core of denser materials such as silicates. The substantial presence of water ice hints at intriguing geological and potentially biological processes beneath its surface, presenting a dynamic and complex world ripe for further exploration and study. Ceres might have harbored liquid water in its past, particularly if its core was warmed by radioactive decay during its early history. This distinct internal structure sets Ceres apart from its asteroid neighbors and prompts tantalizing questions about its capacity for geological activity and the role water played in its evolution. Moreover, the discovery of ammonia-rich clays on Ceres suggests that this dwarf planet may have originally formed in a cooler part of the solar system before migrating inward. The presence of ammonia could lower the freezing point of water, potentially supporting the existence of surface brines. These insights into Ceres' composition and history not only deepen our understanding of this intriguing celestial body, but also offer valuable clues about the processes governing the formation and evolution of icy bodies throughout the solar system. Cryovolcanism on Ceres is particularly fascinating. Unlike the traditional volcanoes on Earth that erupt molten rock, cryovolcanoes, or ice volcanoes, expel materials such as slushy water or brine, painting a picture of a dynamically active world that defies the common perceptions of cold, inert celestial bodies in our solar neighborhood. Water, ammonia, or methane, these substances thrive as liquids or gases in the frigid environments where cryovolcanoes on Ceres are discovered. Cryovolcanoes on Ceres operate by allowing briny water to ascend to the surface, where upon contact with the vacuum of space, it rapidly sublimates, transitioning directly from a solid or liquid state to gas. This dramatic process leaves behind shimmering, reflective salt deposits. These residues create the enigmatic bright spots that mark the surface of Ceres, captivating observers with their luminous appearance. The most renowned of these bright spots is located in a crater named Alcator, referred to as Spot 5. This region has drawn significant attention due to its intense reflectivity and the periodic hazes captured by the Dawn spacecraft. These hazes are thought to be the result of water sublimation, hinting that cryovolcanic activity might still be ongoing or occurred relatively recently on Ceres. Beyond Spot 5, Ceres is dotted with several other luminous areas, each exhibiting its own distinctive features. These spots are not isolated, but are spread throughout the dwarf planet's surface, suggesting that cryovolcanism is a widespread and dynamic geological phenomenon on Ceres, adding layers of complexity and intrigue to our understanding of this distant world. The presence of these radiant spots on Ceres illuminates the dynamic and active nature of this dwarf planet, shattering the old belief that it was geologically dormant. As the Dawn spacecraft captured increasingly detailed images, a diverse array of surface features began to unfold. Ceres' surface is peppered with craters, each narrating a chapter of the planet's storied past. The James Webb Space Telescope, known for its unparalleled ability to peer into the depths of space, has made a groundbreaking discovery. Positioned over 1 million miles from Earth, Webb's powerful lenses and sensors detected faint glimmers of light emanating from a previously unknown planet. This isn't just any light. These are patterns that suggest something incredible. Could it be signs of an atmosphere, or even more tantalizing indicators of activity? Upon receiving the data, astronomers went to work, analyzing the wavelengths and intensities of light. This isn't like anything we've seen before. The planet, located in a habitable zone of a distant star, shows signs of artificial light similar to how Earth would appear from space during nighttime. This segment dives into the technologies used in this analysis and the potential implications of finding such signals. The presence of light is profoundly provocative because it hints at the possibility of life. If these lights are indeed from some form of energy use, what does it say about the beings using it? In this part, we explore the scenarios of what kind of life could exist there. Are we talking about a civilization like ours, or something entirely different? How does the James Webb Telescope manage to capture such faint signals from another galaxy? Here, we break down the science and technology behind this incredible instrument, the mirrors, the sensors, and the algorithms that allow astronomers to gaze so accurately into the far reaches of the universe. This discovery opens a new chapter in space exploration. What are the next steps? More observations are scheduled, and the scientific community is buzzing with excitement. This section will discuss future missions inspired by this discovery and how they aim to further unravel the mysteries of our universe. The James Webb Telescope represents a giant leap in space observation compared to its predecessors like Hubble. With infrared capabilities, it can see through dust clouds and detect distant objects that other telescopes couldn't. In this segment, we discuss the specific technologies that make it possible, including its gold-coated mirrors and sunshield. One of the most exciting aspects of this discovery is the potential presence of an atmosphere. Scientists have detected unusual spectra that suggest the planet may have gases like oxygen or methane, which are potential indicators of life. This segment will break down what we know so far about this mysterious atmosphere. The light detected on this new planet is raising more questions than answers. Are these signals natural, perhaps from glowing gases, or could they be artificial, generated by intelligent beings? Here, we explore the debate within the scientific community and the different theories surrounding the origin of these lights. What if we wanted to visit this planet, or even colonize it someday? We'll discuss what conditions are necessary for human life, and how close this planet might be to meeting those criteria. From temperature to gravity, we'll examine the challenges and possibilities. What if we wanted to visit this planet, or even colonize it someday? We'll discuss what conditions are necessary for human life, and how close this planet might be to meeting those criteria. From temperature to gravity, we'll examine the challenges and possibilities. The massive amount of data coming from the James Webb Telescope requires cutting-edge AI to sift through it. In this segment, we'll talk about how machine learning algorithms are used to detect patterns and insights in the data that human eyes might miss. This new discovery is just the latest in a long line of fascinating exoplanets found over the past few decades. We'll review some of the most significant exoplanet discoveries and what they've taught us about the diversity and potential for life across the galaxy. The sheer distance of this planet from Earth makes it an impossible journey with current technology. But in this segment, we'll speculate about future technologies like warp drives or wormholes that could one day bring us closer to exploring distant worlds. The SETI project has been scanning the skies for signs of intelligent life for years. Could this new planet be the breakthrough they've been waiting for? We'll discuss how this discovery could influence future SATI efforts and the protocols in place if a signal is detected. The discovery of lights on a distant planet reignites the age-old question posed by the Fermi paradox. If intelligent life is common, why haven't we encountered it yet? This segment explores how this discovery fits into the paradox and what it means for our place in the universe. Discoveries like this bring the world's space agencies together. ESA and other agencies may collaborate more closely than ever to study this planet. We'll discuss the potential for international cooperation in future missions focused on this mysterious world. If intelligent life is found, what then? Should we attempt to communicate or leave them undisturbed? We'll explore the ethical and philosophical questions surrounding the idea of contacting extraterrestrial civilizations. From movies to video games, the idea of discovering life on another planet has been a staple in pop culture. This segment discusses how this real-life discovery might influence upcoming sci-fi works and popular media narratives. Believe it or not, amateur astronomers and citizen scientists play a vital role in space exploration. This segment explores how you can get involved in projects that analyze data from telescopes like Webb and contribute to groundbreaking discoveries. If Earth becomes uninhabitable one day, we might have to look for a new home. Could this newly discovered planet be a candidate? We'll dive into the prospects and challenges of establishing a human colony on a distant world. Whenever a new planet is discovered, it eventually gets an official name. We'll talk about the process behind naming planets, who gets to decide, and what this new world might be called. The technologies developed for the James Webb Telescope are not only revolutionizing space exploration, but also influencing innovations in other fields. We'll explore how these advancements could trickle down into everyday technology and other scientific applications. The James Webb Telescope is rewriting textbooks with every new discovery. This segment focuses on the broader impact the telescope is having on our understanding of the universe, from star formation to the evolution of galaxies. What's next in the research pipeline? Scientists have just scratched the surface with this discovery, and much more data is needed. We'll look ahead to upcoming observations and when we might get more detailed information about this intriguing planet. When we contemplate the possibility of life beyond Earth, it forces us to reflect on our own existence. We'll discuss the philosophical and spiritual questions that arise from this discovery and how it shapes our understanding of humanity's place in the cosmos. Even if this planet turns out to be devoid of life, the search itself is still incredibly valuable. We'll talk about how the journey of exploration, regardless of the outcome, leads to new technologies, knowledge, and a deeper appreciation for our own planet. With companies like SpaceX pushing the boundaries of space tourism, could the private sector play a role in exploring planets like the one discovered? This segment explores the intersection of commercial space travel and scientific discovery. Space discoveries have a way of influencing more than just science. We'll explore how this latest finding might affect geopolitics, international collaborations, and even economic trends in industries like aerospace. For those fascinated by these discoveries, we'll provide tips on where to get reliable updates, whether it's following NASA's latest missions, tuning into space podcasts, or joining online communities focused on space exploration. If intelligent life is found, communicating with it won't be straightforward. This segment discusses the vast distances involved, the time delay in messages, and how we might develop a universal language to communicate with other civilizations. If this newly discovered planet is habitable but not ideal for human life, could we terraform it? We'll explore the science of altering a planet's atmosphere and environment to make it more Earth-like, and whether that's feasible with current or future technologies. This planet exists within a larger star system that might host other interesting worlds. We'll take a closer look at the star it orbits, its solar neighborhood, and whether there could be more discoveries waiting just next door. Water is a critical ingredient for life as we know it. In this segment, we'll discuss whether there are signs of water liquid, ice, or vapor on this planet, and why that's such an important clue in the search for life. The discovery of exoplanets is relatively recent, but it has grown rapidly in just a few decades. We'll walk through the history of exoplanet discoveries, from the first confirmed detection to today's advanced telescopes capable of finding Earth-like worlds. One of the most fascinating techniques used in modern astronomy is gravitational lensing, where light from distant objects is bent by gravity. We'll explain how this technique is helping scientists find new planets, including possibly this one. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.